Hello, everyone. It is great to be here at P99 Conf. And today we're here to discuss a little bit of Concurrent React, some internals, and some of the new APIs shipped with React 18. This is me. I am Matheus Albuquerque. I am a Google developer expert in performance. I'm a senior software engineer at Medallia. I mentor front-end students at Tech Life Berlin, and you can find me everywhere as Y Combinator. And by the way, these slides and other slides I have on performance and journals and etc. They're available over this QR code. So before we start, I do have a disclaimer. So the session is kind of a deep dive, mostly if you're interested in API discussions and etc. But you don't need to know all of that to be like a productive developer with React. So to start today, I'd like to propose this mental exercise of summarizing what you know so far about Concurrent React in one word or expression. So I'd like to have you thinking about that for now, but let's take a step back and talk about the main thread. So you're probably familiar with the idea of long tasks. So it happens, for example, when we have our inputs blocked or a link that is not responsive or a button, etc. It's terrible. And if you have in the past debugged these, you know these red flags we get in the profiler in Chrome Developer Tools. And not only they're bad, but they result in things like, for example, rage clicking. That is when a user clicks a button multiple times because there's no visual response to that click. And not only it happens a lot, but we have metrics for this. First input delay is one of them, but we also have newer metrics created and etc. So we also have research around the topic. And for example, a few years ago, the Web Almanac realized that on mobile, it's even worse. So it could be 7 times slower for first input delay. And when you correlate these metrics with like your business metrics like conversion rates and etc., you see that there is a business outcome on having like things like slow TTI, slow first input delay, etc. So we want to discuss here how we can avoid blocking the main thread in the first place. And to do that, we have to discuss task running strategies. So let's say we have these 4 tasks, A, B, C, and D, and we want to run them. So we can go with parallelism, where we would have like multiple threads, and we would have multiple tasks running in the separate CPU cores. We could talk about concurrency, where we would have just a single thread, but we quickly switch between tasks so that they feel instantaneous for the users. And we can talk about scheduling. That is when we have this concurrency model, but we have a scheduler that is assigning different priorities to different tasks. So let's start with parallelism. So in parallelism and browser, we're usually talking about web workers. So in web workers, we have data exchange through message passing. And because of that, there's no access to variables or code from the page that instantiated a worker, or vice versa. You don't have access to the DOM either, so it's quite complex to make UI updates from a worker. And if you're creating an application using web workers, you usually end up with 2 abstractions, actors and shared memory. So the actor model you've probably been familiar with if you've done Elixir or Erlang in the past. So basically, we have this abstraction of an actor that fully owns the data it is operating on. And these actors, they can only communicate via message passing. In this abstraction of browsers and workers, we can think of the main thread as the actor that owns the DOM or the UI. But the thing here is post message, the method we have, has no built-in understanding of request and response. So what happens is we end up having to balance, okay, we're offloading this to a worker to improve performance, but just the communication overhead of having to serialize everything, and that worker might be busy and we have to handle that with our code. The other abstraction is the shared memory model. So it happens using this shared array buffer type. And the great thing about shared array buffer is if you send it via post message, the other end is going to get a handle to the exact same memory chunk, which is great. But we're talking about JavaScript, we're talking about browsers. So most of the web APIs that we have these days, they were built in the past without the idea of concurrent access to objects. So here we end up having to build our own concurrent data structures like mutexes and etc. And last but not least, there's no way of working on familiar objects, arrays, or other JavaScript stuff. We're just handling a series of bytes. And then there's WASM, which is probably the best experience for sharing memory model. But again, you don't have the developer experience of traditional JavaScript frameworks. And another gotcha is WASM is faster when you stay within WASM. But the more you cross this boundary and start doing DOM and UI updates, etc., you'll see that it doesn't necessarily outperform other frameworks like Inferno or Svelte, Solid, etc. Before we move forward, I have to say that workers are great, and we have a lot of great open source there. Conlink and WorkerDon are amazing libraries that make the whole experience of doing workers way better. And it's even like experimental ideas like PartyTown that offloads third-party libraries to web workers automatically for you, which is also great. But overall, I have this sensation that workers, they're great for heavy data processing and etc. But they tend to be hard to use for UI related stuff. And sometimes it might be harder than adjusting the UI work you have for a scheduler. So that's when we get to talk about concurrency and scheduling. And back to the question I asked a few minutes ago about summarizing. If I were to summarize concurrent React in one word, I would go with scheduling. So internally in React, we have this cooperative multitasking model where we have a single rendering thread that is interoperable. And because of that, the rendering process can be interleaved with other main thread tasks, including other React renders. It's also because of that an update can happen in the background without blocking the response to new input. So it's better if we can visualize. So it works like this. Let's say we have an original render task and then some user input or something that has high priority happens. So it handles these tasks and then it resumes the original render one. And if we check the source of React, we're gonna see this perform work until deadline function. So basically, React has this queue of updates, and this function handles that. And in React 17, you would start processing that, and you keep processing until you're all done. And most likely, the main thread would be blocked during that. The difference with React 18 is that we have this should you to host function that basically tells React whether it should yield the control back to the browser or not in the meantime. And the heuristics we have here is it yields execution back to the main thread every 5 milliseconds. And I know it looks a lot like a magic number and everything, but it's not. It's just smaller than a single frame, even if we're talking like 120 FPS devices. So that's why it doesn't block animation. And that's what makes, in practice, rendering interruptible. So I know that a lot of these things about internals are really, really interesting and etc. But I still get a lot of the questions like, okay, I don't work in the core of React. I don't mind a lot about the internals. So how can I use that on a daily basis? And for that, I'd like to start talking about scheduling for the rest of us. And I gathered 4 different scenarios that we might benefit as React developers of what's enabled by these internals we just discussed. So the first one is handling large sets of data. So there's a lot of practical examples out there talking about, for example, how you can run an algorithm to find prime numbers or crack passwords or even rendering fractals on React components. And these are great for benchmarking, but a lot of developers, they don't see how they could use these practical examples on a daily basis. And I think we should think about things we front-end developers do a lot. So it's common that we have to render many data points in a component, or we have to render something on the canvas and we don't have off-screen canvas available in our target browsers, or that we have to process a lot of data. These are common things that happen. Here's one example, a virtual example where we have a timeline component and we have records, and basically you can filter the time span of the records using this timeline component. And the whole thing looks like this. So we have an effect that sets some initial data. We have an unchanged handler, and then we have our dashboard component. And as you can see, that example, the animations were not great. So they were lagging a bit, and it wasn't a very responsive user experience. So I like to experiment and change that by wrapping with a transition or set data method. And now what we have is a way smoother experience. So you can notice that no matter how big the interval is or how many times I change that, it's not lagging at all. The browser is smooth, everything is smooth. And when I started seeing this kind of examples, I was really thinking about applications I built years ago that I feel like could benefit of this. And one, for example, was this map rendering application. We had about 100,000 data points plotted to a map, and you should be able, the users, they would have to search and filter those data points and etc. And at the time, we used a lot of web workers. We used Redux site utilities for task parallelization, cancellation, race conditions, etc. And we used things like the bouncing. But in the end, we could perhaps have used better scheduling primitives like transitions. And another example is this admin panel for an app that, again, I built years ago. So we had thousands of real-time players that changing messages. And as an admin, again, you should be able to search and filter these messages. So at the time, we used a lot of virtualization and memorization techniques to improve performance, but we could have used better scheduling primitives, perhaps. Another scenario is tackling wasted renders. So we're constantly trying to improve performance of our components by doing so. There's this hook called use sync external store that was introduced in React 18. And it was initially sold out there as a part of the umbrella of Concurrent React for library maintainers. And some libraries even adopted it, like React Redux, for the sake of being compatible with React 18. But again, I see a lot of people, they don't realize how they could benefit from some of these less popular hooks on a daily basis. So one thing we do a lot is React Router. So here's an example using React Router version 5. And it's use location hook that gives us information like path name, hash of the route, and etc. It's a great hook because it gives us a lot of info, but it's also what some people call an over-returning hook. So let's see how that component renders. So you can see here that I'm changing only the hash of the URL, but the path name component is also re-rendering, and we don't want that. So we could go from this to this, where we have our custom use history selector hook, and inside this hook we're using use sync external store, and then we consume that, creating our path name and hash selectors. And the end result is that now only the hash component re-renders, which is what we expected. Another thing is hydration. So if you've done SSR or with Next or something else in React before, you know, you've seen this, that all of these steps, they're sequential and blocking. So here we have, we render the HTML on the server, and that's when we got the first byte, and then load the code on the client, and that's when we got our FCP. And then we have to wait for hydration to get our interaction. And that was bad because the whole hydration could only begin after the entire data was fetched and rendered. So users couldn't interact with the page until the hydration for the whole page was done. And because of that, parts of the app that were fast, they would have to wait for the slow ones, which is not great. With the new Concurrent React, umbrella in React 18 with suspense SSR and hydration improvements. This goes to this, where we have all of these metrics faster. And that uses you can leverage that by using the pipe to node string API with create hook and using suspense in your components. And by doing so, React is going to prioritize hydrating the parts of the app that the users interacted with before the rest. And because of that, components can become interactive faster by allowing the browser to do other work at the same time as hydration. And the bottom line here is that React no longer has to wait for huge components to load to continue streaming HTML for the rest of the page. And when the HTML becomes available on the server, it is inserted in the right place by React. And we even have cases out there like Vercel. They improved the performance of their Next.js website using these features, and they improved the total blocking time and their INP as well. Last but not least, we not only want to build our apps, but we want to debug them. So there are some enhancements in the profiler. We have this scheduling tab that we can use to proper inspect our transitions. And my favorite part are these smart hints that basically the profiler is going to detect long tasks you have and suggest that you might wrap them with a transition, for example. There are just a lot of things, amazing stuff coming down the line. So I'd like to quickly go through some of them. So we're gonna have more IO libraries like React Fetch, built-in cache for data fetching libraries to integrate with Suspense. We're gonna have Suspense for CPU bound trees, which is just amazing because you can fall back some expensive subtree of your component without even trying to render. We're gonna have more hooks for library maintainers like use insertion effect. The off-screen component, which is also amazing. Just this whole umbrella of React server components. And outside of React, there's also the native scheduling primitives to the browsers. So if you haven't seen, I would recommend you to check this prioritized task scheduling API. That is basically an umbrella of different APIs that all aim to bring a more robust solution for scheduling the browsers in a way that is promise-based and directly integrated into the event loop. And it's an effort of the React core team, some core teams at Google, the web consortiums, and many other teams. And again, it's an umbrella of APIs that you have APIs for using execution back to the browser, or scheduling controlling tasks, or checking if the browser is busy handling some input, and many of them. Facebook has pushed a lot, some of them in the past. Airbnb also has cases of using them. And on GitHub, you will find also open source projects that are inspired by the spec of this API. A few closing notes before we leave. So there's this talk by Rich Harris called Rethinking Reactivity, which is a great talk. And in this talk, he basically mentions that React is not reactive by definition. And he's right, but it's more and more concurrent. It has better and better scheduling primitives. And that might be enough for you and your apps. Another thing is this tweet by Guillermo Roch, the CEO of Vercel, a few years ago, where he said that React is such a good idea that we would spend the rest of the decade exploring its implications and applications. And I think that the scheduler API is one good example of these implications and applications, because React has been pushing a lot of web APIs to the future. It's also important to highlight that scheduling doesn't necessarily mean you're going to have better performance. So just like anything else, you have trade-offs. For example, non-urgent updates that might take longer if you're using scheduler primitives. You might have extra CPU costs. Or, for example, you might not be able to optimize some really expensive components you have. So the cliche of there's no silver bullet is also a thing here. So it's important that you to identify your core metrics. And another thing also related is there's a lot of information out there. And you're gonna see the core committers, the core team, and a lot of people making really good points. And it's hard to piece together all of these points on performance, and scheduling, and all of these topics. So it's important that you, when using things in your apps and etc., that you correlate your business metrics with your performance metrics. Things like conversion rates, bounce rates, etc. The behavior of your users is what matters in the end when discussing performance and anything else. So yeah, I am Matheus. It was great to be with you today. Thank you so much, and let's connect.